All right, completing the identity. My suggestion as you watch these is to perhaps get a clean sheet of paper, write down all the problems, and then after you've watched the videos, after you feel like you've reviewed for your test, go back and see if you can do these yourself, okay? So there are 9 problems here. The first one says, we're asked to complete the identity, and this one is sine of theta times cosecant of theta. Well, if you recall, these two are reciprocal functions, so it could be said that sine of theta, you could write cosecant as 1 over sine of theta, and the sine of thetas cancel, so the answer to this is 1. Similarly here, we have tangent of theta times cotangent of theta. Well, cotangent is reciprocal of tangent, so it can be written like this. Tangents cancel, so you get 1. These come from your reciprocal identity. Sine and cosecant are reciprocals, tangent and cotangent are reciprocals, secant and cosine are reciprocals. So this one says secant of theta times cosine of theta. Let's say if our general rule when you're dealing with sine and cosine is that if you could write things in terms of sine and cosine, let's say we write secant in terms of cosine, so it's 1 over cosine times cosine of theta. Cosines cancel, and we get 1 here also. So all of these came out to be 1. All right, the next one, this is not going to come out to be 1. But remember we said our rule was we're going to write things in terms of sine and cosine if we can. So I have cosine b times cotangent of b. So I'm going to have cosine of b, that's already in terms of sine and cosine. But I'm going to write cotangent as cosine of theta, or cosine of b over sine of b. Then our rule says dividing fractions easy as pi, flip the bottom and multiply. So I have cosine of b times, I'm going to flip the bottom here and multiply. So this gives me sine of b over cosine of b, because I flipped the bottom. The cosine of b's cancel, so my answer comes out to be the sine of b. All right, 5, 6, and 7, these are Pythagorean identities. 1 plus tangent squared of theta is equal to secant squared of theta. I like to remember it as I, tan, and a sec. Pythagorean identities have the qualities of every term as squared, so I recognize that all of these are Pythagorean identities. The next one, 1 plus cotangent squared of theta is cosecant squared of theta. I like to remember it, I cut cheesecake. And then this was really our primary one. Sine squared of theta plus cosine squared of theta is equal to 1. Okay. All right, and if you look up at number 8 here, it says cosine squared of theta minus 1 over cosine of theta plus 1. Well, I recognize that the numerator here is the difference of 2 perfect squares, so I'm going to factor it. So it'll be cosine of theta plus 1 times cosine of theta minus 1 over cosine of theta plus 1. Kind of put them in parentheses to remind myself these are factors. This cancels just like this. So my final answer is going to be cosine of theta minus 1. At this point in the game, I always have students go, how do I know that I'm done simplifying? Maybe I could simplify more. Well, your test is going to be multiple choice, so I think you'll probably recognize it. You'll find the answer you want. All right, and lastly we have number 9. Said sine squared of theta plus cotangent squared of theta plus cosine squared of theta. All right, one of the things that happens frequently is they'll put sine squared of theta and cosine squared of theta together. And we know from number 7 that said sine squared of theta plus cosine squared of theta is 1, that I could just substitute 1 for sine squared of theta plus cosine squared of theta. So that gives me 1 plus cotangent squared of theta, which is actually another Pythagorean identity. I cut cheesecake. So that is going to be my answer for number 9.